Hello friends, I was working with uh, Latin squares and Greco-Latin squares where you arrange n digits in an n by n square grid so that no row or no column has any duplicate. So I was thinking of introducing the diagonals also. How many distinct digits you will need if you fill up an n by n square grid having no duplicate in any row or any column or any diagonal or any broken diagonal. So these are columns, these are rows, these are diagonals, and broken diagonals are 6, 8, 7, 5 or 8, 5, 6, 7 or 6, 1, 7, 4, and another broken diagonal is 8, 4, 6, 1. So for any general number n, how many minimum number of distinct type of objects you will need to fill up an n by n square grid such that there is no duplicate in any row or any column or any diagonal or any broken diagonal. So the numbers I have got is for a 1 by 1 square you need one type of number. You need all the number type is only one. For 2 by 2 square you need distinct numbers in each cell. So if I want to show you, if I go to 4, if I go to 2, you fill first cell with 1, then second cell has to be distinct because it's in the same row, so 2 goes there. Third cell has to be distinct with 1 since it is in the same column, and also has to be distinct with 2 because it is in the diagonal. So 3 comes here. Now for the fourth cell, it cannot be 1 because it's in the same diagonal. It cannot be 2 because it's in the same column. It cannot be 3 because it's in the same row. So it has to be 4. So for a 2 by 2 cell, you need n square digits. For 3 by 3 cells also, you will need n square distinct digits. All the digits should be different. Otherwise, they will I mean number in this cell has to be distinct with 6 and 1, has to be different from 8 and 3, has to be different from 2 and 4 because it's in the same diagonal, and has to be different from 7 and 5 because it's in this broken diagonal. So for a 3 by 3 grid, you need 9 digits, which is the maximum. Okay, the number of distinct digits has a lower bound n because you need n distinct digits in any row, so it has to be bigger than or equal to n, and has to be less than equal to n square because for an n by n grid there are n square cells. So maximum number of distinct digits you need to fill up n square cells is n square. So for 3 we have reached maximum. For 4, the game changes a bit. You can start filling up the cells, but the maximum number of digits depends on the order you fill in the squares. So here we get 9 as the maximum numbers to fill up 4 by 4 grid, but I have got 8, which is better. So let me try another way. Let me try. So this way you get the maximum number as 8, which matches with my best performance, with my match with the best minimum. There are another type of movement to fill in the squares, maybe first row, then first column, then remaining second row, then remaining second column, then remaining third row, then remaining third column. the remaining fourth row, fourth column. But in this way you get 11. So the maximum number depends on the order you fill in the squares. So these are different numbers which are quite non-trivial. I don't think there could be any mathematical formula to digit the maximum number of digits you need to fill up an n by n square grid, so that no row, no column, no diagonal, and no broken diagonal has any duplicate. So let me try 10. If I could improve this number 18, let me try 10. Let me try the way in which I got the minimum for 8. So to fill up the first row, you will need 10 distinct numbers, but the numbers get repeated in the second row. It has to be 12 because it has to be different from 11, 6, 5, 8, 7, 2, 1, 4, 3. Has to be distinct from 10, has to be distinct from 12, and has to be distinct from 1 because 1 is in the broken diagonal. So let me see if I could fill in this 10 by 10 grid with numbers less than 18. I call them super squares. Since I was studying Latin squares and Greco-Latin squares, so I call this super squares. So the idea came from Latin squares, where you avoid having duplicates in any row and any column. So in super squares, we avoid having duplicates in any row, any column, any diagonal, and any broken diagonal. For a 4x4 grid, you need minimum 8 distinct numbers. So I got 17. No, I got 18. Okay, so the 18 is still now the minimum number of types of minimum distinct numbers to fill up a 10 by 10 grid, so that no row, no column, no diagonal, and no off diagonal, broken diagonal has any duplicate. I think it's a nice concept and nice problem. Thank you.